Alrighty. So we only have one more quiz left in this chapter, and it'll just be over section 5. Let me verify that. Yep, only over section 5, so we are almost done with this chapter. We will be having a test this week. All right, number 1. Here we go. Number 1, all it says to do is factor. So 6a squared minus ab minus b squared. Okay, I take a look at this first term and the last term, and my little my shortcut says, okay, if the first term and the last term are perfect squares, then I may be able to do my little shortcut. So let's check. The square root of 6a squared. 6 is not a perfect square. A squared is, but 6 is not. So that stinks. I'm not going to be able to do my little shortcut with this one. I've got to factor it out like normal. Okay. Since the coefficient of that first term is not a 1, we have to go the long way. So first thing we do is multiply a times c. So 6 times, that's a -1. So a times c is -6. My b value is -1. So here I need to come over here and I need to list out the factors of -6. So I've got 1 and -6, -1, +6, 2, -3, -2, +3. And which one of those factors combine to get a -1? Well, that would be 2 and -3. Once I found that, I go back to the original problem and I split it up. So 6a squared, I split up that middle term. So I'm not going to write -ab anymore. I'm going to say plus 2ab minus 3ab, because 2 minus 3, that's still -1. We're not changing it, we're just rewriting it. Minus b squared. Now I'm going to separate. I'm going to split up the factors. Plus a -3ab minus b squared. All right, what can factor out of these two terms? I can pull out a 2 and an a. Anything out of here, I can factor out a negative from both of them, and I can also factor out 1b. So here we go. I've got 2a, and I'm left with 3a plus b. And then I pulled out a -b here. So I'm left with a +3. B's cancel out, so I'm left with a +3a. A negative divided by a negative, that's a positive. B squared over b. There we go. Okay. Can I factor anything else out? Yes. I can pull out that 3a plus b. That acts as a factor. So I've got 3a plus b. And what am I left with? 2a minus b. There we go. Any questions on number 1? Okay. Did we get that one correct?
I did.
Yeah. Harley, did you get it right, or do you see what you did wrong?
I see what I did wrong.
Okay. All right. Again, remember, always show your work because you can still get partial credit. All right, Harley, what's the first thing we need to do on this one, number 2? When we have a trinomial or anything that we're factoring, the first thing we always ask ourselves is what?
If there's anything that can go into all of them.
Exactly. Is there anything I can factor out? Now, let me ask you this. What if you forgot to ask yourself that? What if you went straight to a times c is 6 times -20, which is -120? Would you still get the right answer if you didn't factor it out? Yeah. Yeah. You can still get the same answer. Now, it may be a little bit harder because you've got higher factors you're dealing with. Then I'd have -120. Finding the factors of -120, that add together to get negative 26. So it'd be a little bit more work, but you can still do it. I'm going to go ahead and factor out, let's see here, a 2. I know I can pull out a 2 out of all these. So pull out that 2, I'm left with 3r squared minus 13r minus 10. Okay, that's a little bit more reasonable. Check that first and the last term. Are they perfect squares? No. Therefore, I have to go the long route. Here we go. Multiply that first number times your last term. So that's 3 times negative 10, which is negative 30. Your b value is negative 13. So I need factors of negative 30. That will get me negative 13. You know, I'm not even going to do 1 and 30 because I know that 1 plus 30, I'm not going to get 13. Let's see. What about 2 and negative 15, negative 2 and 15? Uh-oh. Okay, this one of these might do it. 2 minus 15. Oh, there we go. I'm not even going to list out anymore. Now, you may be asking yourself, well, what about, 3 and negative 10 and negative 3 and positive 10. But remember, when we're doing the long, call this the long version of factoring, if it's a negative right there, your factors have to be positive and negative, or negative and positive. If I had 3 and 10, or negative 3 and negative 10 as my factors, okay, then negative 3 minus 10, that would add up to be negative 13. But I can't use those factors because my factors, because a times c was negative, my factors also have to be negative. So I can't use these ones. I have to use 2 and negative 15. So here we go. Next thing I'm going to do is I'm going to just rewrite my trinomial. So 3r squared, instead of writing negative 13r, I'm going to do positive 2r minus 15r minus 10. All right. I've got that going. Let me ask you this. Can I swap these two? Can I swap 2r negative 15r? Would that still be the same thing? If I said negative 15r plus 2r, is that still negative 13? Well, sure. Why do you think I would do that, Sierra? What would be the benefit of switching negative 15r and 2r? You don't have to, but why?
So you can, like, factor it out better?
Okay, I definitely like, now when we split up our factors, I definitely would rather factor 3 and 15 because those are, 3 is a factor of 15. 3 wasn't a factor of 2. 2 wasn't a factor of 3. So, and now 2 and 10, those are nice factors to work with. So that would be the only reason why I would split those up. So rewrite your polynomial, split them up, and then now let's factor out. I can factor out a 3 and an r here. Here I can only factor out a 2. So remember your original 2 that I factored out of the problem. Here we go. I pulled out a 3r, and I'm left with r minus 5, plus I pulled out a positive 2, and I'm left with r minus 5. Last step, I can pull out an r minus 5, and I'm left with 3r plus 2. And there is your final answer there for number 2. All right, any questions on number 2? Okay, hopefully this is a good review for you. 16x squared minus 24x plus 9, okay. I don't see, can I factor anything out of all 3 terms? Well, no. Next thing I want to look for is, okay, is this a perfect square trinomial? If it is, this is going to be a breeze, all right? So check out that first term and the last term. Can I take the square root of 16x squared? Yes, I can. That's 4x. Can I take the square root of 9? Yeah, that's 3. Okay, so that's the first thing. The first thing is, okay, is the first term and the last term, are they both perfect squares? If that is the case, all right, what's my next step to do? Y'all remember? If both of them are perfect squares, then there's one more thing I have to determine. You might remember? How do we check if this whole thing is a perfect square trinomial? Remember, take the first term, multiply it by the last. You take your a value, 16x squared, multiply it by your last term, and then you take the square root of that. Is this ringing a bell? So if you multiply the first term and the last term in your trinomial, so here I can split this up. I can say the square root of 16, the square root of x squared, and the square root of 9. So that's 4 times x times 3, which is 12x. If I take the square root, let the first and the last terms multiply together, I take that square root and I multiply it by 2. If that product is my middle term, then this is a perfect square trinomial. And my answer will be, so remember this is in the form ax squared minus bx plus c squared. My answer will be in the form a minus b squared. Ringing a bell?
Yes.
Okay. So, if I want, did I do that right? Okay, so where do I go from here? Make sure I got that. Oh, excuse me. This is b squared. Thought that looked a little funky. I'm getting my things mixed up too. So I'm thinking of a different thing. Sorry. A squared minus ab plus b squared. There we go. So this is in the form. All right, so 16x squared is represented as my a, 24x is my ab, 9 is my b squared. So this is a minus and a plus. So my answer is going to be this binomial, a minus b times a minus b, or a minus b squared. Okay, what's my a value then? Harley, what's my a value going to be? If 16x squared is represented as a squared, what would just a be?
4.
4x. And then my b value, if 9 is b squared, how do I just get b? I have to take the square root of it. There we go. 4x minus 3 squared. And then, let's see here. Number 4, this one, a lot more familiar. 4y squared minus 9. Check out that first and the last term. They're both perfect squares. So my answer is going to be a minus b, a plus b. But remember, this is in the form a squared minus y. A squared minus b squared. So in order to get a, I have to take the square root. So 4y squared is a squared. But in my answer, I just want a. So the square root of 4y squared is 2y. Square root of 9 is 3. 2y plus 3. There's number 4. All right, and then number 5, what's the first step in factoring any polynomial? Factor out whatever is common. Oops. So if you just said factor, I'll take that. Factor out a common monomial, factor out a common term. That was what I'm looking for. That's always your first step. Is there anything in common with all 3 of these terms that I can pull out? And then number 6, fill in the blank to make z to the 8th plus something plus 144. Now we have to make that a perfect square trinomial. Well, first thing is take that first term and the last term. So I've got z to the 8th and multiply it times the last term. Take the square root of that. Now we haven't done a bunch of these, so there may be one of these on the test. All right, so this question right here may not be counted against you just because I didn't show y'all too many of these. All right, so break this up. Z to the 8th times the square root of 144. Now, the square root of 144, we know that, that's 12. What about the square root of z to the 8th power? I haven't taken the square root of anything outside of to the 2nd power. So can I make z to the 8th z squared times z squared times z squared? Oops, I'm missing one. Times z squared. Is that the same as z to the 8th? Is this right here? I've tried to break up z to the 8th into z squared, z squared, z squared, and z squared. Is that the same? What do you think? Is this the same as z to the 8th?
Yes.
Yes, it is. Remember our rule. Multiplying same base, add the exponents. So this is the same base of z, all to the 2nd power, so add them up, 2, 4, 6, 8. So yes, this is the same as the square root of z to the 8th power. And now, I know how to do that. I know how to, oops, not x. I know how to break up. I know what the square root of z squared is. I know what the square root of z squared is for all of these. So that would be z times z times z times z times 12. What would that be? What's z times z times z times z? Harley?
Z to the 4th.
Z to the 4th. Okay, so what have I just done? I'm trying to find this middle term right here. What's my middle term going to be? So the first thing, and they're saying it's got to be a perfect square trinomial. So in order to find that, we would multiply the first term times the last term and take the square root of it. So the square root of z to the 8th times 144. And we just did that. We found the square root of it, which is 12 times z to the 4th. And then we have to multiply that value by 2, which would be 24 z to the 4th. And so that would be the middle term that you would need. Did anybody get that right? All right, are there any questions on that one? Or questions on any other piece of the quiz? Okay. Alrighty. Let's do this. Let's go ahead and because that actually reviewed a little bit of 10.4 for us, I'm going to skip for right now going over the homework that you just turned in for 10.4, and I want to go to 10.5 and get into that. That will be our last lesson chapter. So I want to go ahead and get introduced into this. So 10.5, this is called factoring completely. So hopefully we're going to be seeing common patterns of what we've already been studying as well. So we're just going to build off of what we've already gotten done. Not really a whole lot of new stuff here. All right, let me share it with you guys and we will get going. 10.5. Okay. So just review, we're not going to do too much of this, but if we were to factor 6x plus 12, what can we factor out, Sierra?
A 6.
Okay, so do this in your head. What would your final answer be then? Do you factor out a 6? What you got, Sierra? So remember, when you factor it out, you're dividing everything by the same thing.
Mm-hmm. 6 times x plus 12.
Not x plus 12. Remember, if you factor it out, you've got to divide it by everything. So you pull out a 6, divide both terms by 6. So 12 divided by 6, you're left with 2 inside. Remember to check these. You're going to have to distribute whatever's outside the parentheses to everything inside the parentheses. When you do that, that should get back to your original problem. Harley, what's the common term in this one? What can we factor out of here?
X minus 5.
Okay, so pull out an x minus 5, and what are you left with in the other parentheses? You pull out an x minus 5, what are you left with? Can y'all see this?
7?
Can y'all see the PowerPoint?
Yeah.
Okay. So all we did was we factored out an x minus 5. So if I pull out an x minus 5 here and I pull out an x minus 5 here, what am I left with? Just like, there you go. So x plus 7, x minus 5, there we go. All right, down here, we would factor these trinomials. We'd make 2 binomials, have an x and an x here. Find factors of this last term right here that would add together to get a -1. So x minus 4, x plus 3, x squared minus 81. This is the difference of 2 perfect squares. So therefore, it's going to be in the answer form, a minus b, a plus b, which is x minus 9, x plus 9. All right, and then lastly, we would factor these just like before. X squared is a perfect square, 1 is a perfect square, so therefore we can take the square root of the first term times the last term, which would be x, multiply that by 2, which is 2x. Okay, this is a perfect square trinomial, plus and a plus, so therefore my final answer is going to be in the form a plus b squared. My a value is just x, because you have to take the square root of that. My b value is the square root of 1, which is 1. So factoring completely. All right, what if it's not an integer? All right, we got to be careful. Here we go. Let's go to an example. Factor 5ax to the fifth minus 5ax y to the fourth. Well, first thing I always look for is, can I factor something out that is the same in both? Sierra, what is common in both of these terms that I can factor out?
5 and an A
Mm-hmm.
and 1.
There you go. Very good. A 5, a, and an x. So when I factor it out, that means I'm dividing. So divide both sides by 5ax. I pulled it out here, and I'm left with x to the fourth minus y to the fourth. What does this look like it could be? This looks like, hey, this may be the difference of two perfect squares, right? Is x to the fourth and y to the fourth, are those perfect squares? Okay, x to the square root of x to the fourth, well, that's the same as x squared times x squared. I can take the square root of x squared, that's x. I can take the square root of x squared, that's x, so that would be x squared. So the square root of x to the fourth power is x squared. So therefore the square root of y to the fourth power, I mean, I don't have to do all the work again. I know that the square root of x to the fourth is x squared, so therefore the square root of y to the fourth is y squared. Hey, those are perfect squares. So I can factor perfect squares, factor the difference of squares. Therefore, x to the fourth minus y to the fourth. That's like a squared minus b squared. So my answer is going to be a plus b and a minus b. So again, okay, here's my original, x to the fourth minus y to the fourth. X to the fourth is my a squared value, but in my answer, I want it to be just a, so I'd have to take the square root of x to the fourth. That's what I did right over here, the square root of x to the fourth. So x squared now becomes my a value. Here's my a value, x squared. Here's my a value, x squared. Same for my b value. Well, b squared is y to the fourth. So in order to get b for my final answer, I have to take the square root of y to the fourth, which is y squared. So y squared is my b value, and y squared is my b value here. But I'm not done yet. Because notice in this term down here, 5ax, x squared plus y squared, x squared minus y squared, there is still something else I can factor. Notice this guy right here. Is this the difference of two perfect squares? Can I take the square root of x squared? Yeah. Can I take the square root of y squared? Yes. So there is still more to factor. Just because we did it one time there's something else that we can factor. So x squared minus y squared can be factored. That's in the form a squared minus b squared. Therefore, I need a plus b and I need a minus b. I can't factor this one. I don't have a shortcut that says, oh, factor the sum of perfect squares. No, it's factor the difference of perfect squares. So be careful. We don't have a solution for this one. We can't factor that one. All right, so x squared minus y squared factored is x plus y, x minus y. Okay, anything else that we can factor? No. I would take this as an answer. If you got to this point, I would take this as the answer. Now, oh, excuse me, this is the answer. But how do you check your solution? How would you check it? Well, you'd have to distribute everything, right? Now that will take a long time. I would recommend checking it that way on a test. Probably maybe 1 or 2 on your homework, just to make sure you're getting the right answer. But on a test, you will want to check your work. And how do you check your work? Distribute. Distribute, that's the opposite of factoring. Let's do another one. X to the 4th minus 9x squared plus 8. First thing you ask yourself is, can I factor anything out of all 3 terms? Harley, is there anything I can factor out? Do what?
No.
No, there's no common terms. There's no common variables. So here we go. Are these perfect square factors? X to the 4th, let's see. Can I take the square root of x to the 4th? That's like saying the square root of x squared times x squared. Oh, square root of x squared, that's x. Square root of x squared, that's x. So yes, x to the 4th is a perfect square, but 8's not a perfect square. So we can't do it that way. So here we go. What can I do though? Well, just like we would normally do it. X to the 4th. Take that first term, multiply it by your last term. So, or excuse me, the coefficient. So we gotta do it the old way. 1 times 8 is 8. So list out your factors of 8. We're gonna get 1 and 8, 2 and 4, and that's it. Okay, what combination of these numbers will add together to get a -9, a -1, and a -8? But notice, this first term is an x to the 4th. So therefore, your first terms are not going to be x and x, because x times x is just x squared. We have to get it to x to the 4th, which is why, okay, we're going to have to start with x squared then. X squared times x squared, that will be x to the 4th. And then we can keep checking it by foiling it. So x squared times -8, -1 times x squared, that will get you your -9x squared, and then -1 times a -8 is a +8. So just checking that in my head. Check out these guys, x squared minus 1 and x squared minus 8. Can we keep factoring one of these? Are any of these the difference of 2 perfect squares? Well, let's check. Is x squared a perfect square? Yes. Is 1 a perfect square? Well, square root of 1 is 1. So yes, I can factor this. That's the difference of 2 perfect squares. What about this one? X squared minus 8. Well, 8 is not a perfect square. So I can't factor a, so we're just going to have to leave this one alone. All right, so x squared minus 1. So that's going to be, this is in the form a squared minus b squared. Therefore, my answer is going to be in the form of a plus b and a minus b. And then x squared minus a is going to be left to itself. And there we go. There is my final factored answer. Any questions so far on these first 2? So all we're really doing is we're factoring, and then we're factoring again. 2xy minus 7x plus 10y minus 35. Well, this one's gonna be fun. Do I have something that I can pull out of all 4 terms? Now this is a polynomial, it's not even a trinomial. No, there's not. I don't even have a value that has x squared or y squared in here. So what do I do here? Well, just like when we were factoring previously, we would regroup our terms together and then factor out those 2. Remember when we had x squared minus 2x plus 3x minus 6? Remember when we rewrote that middle term there? And then we said, okay, let's group these together And then let's group these together. Okay, now I can factor these ones out. I can factor out an x here, an x here. I can factor out a 3 here and a 3 here. That's exactly what we're going to do right here. But here's what we have to do. We have to look at all of the terms and say, okay, which ones should I group together? Should I group together the 10y and the 35? Okay, well, if I do, what could I pull out of that? There's a common factor of 5. I could pull out a 5 from those. What about here? Well, I could pull out an x. Sure, you could do that, but it may be better to maybe group 2xy and 10y together, because then you can pull out a 2 and a y. Group maybe 7x and 35 together. Then I can pull out a 7. Is there a certain way to do it? No. See, the book's doing it. Well, let's just group together 2xy and 7x. Sure, that works. Doesn't matter which ones you group together, because you can rewrite the order of your variables, or excuse me, of your terms. Just keep the signs the same, though. Be careful that you don't mix up the signs. So here we go. What can I factor out of these two terms now? Well, I can pull out an x here. If I pull out an x here and an x here, a 5 here and a 5 here, pull it out that x, I'm left with 2y. Pull it out an x here, I'm left with -7. Same over here. Now notice, I can pull out a common factor of 2y minus 7. And what am I left with? 2y minus 7 times x plus 5. All right, let's do one more. an minus pn minus pn. Oof. Same thing here. Group together, common factors. am and an both have a common factor of a, so I can pull out an a there, plus a negative pn plus pn. They both have a negative p that I can pull out of both of those. So here we go, pull out that a. I'm left with m minus n. Pull out a negative p. I'm left with m minus n. Pull out that m minus n. And what are you left with? A minus p times m minus n. All right. I want you to go ahead for homework. Here we go. All right, for homework, we're going to do pages 426 to 427. I want you to do numbers 1 through 20 all. Okay, I'll put that on Google Classroom. So page 426 to 427, numbers 1 through 20 all. You have the back of your book to check the odd numbers, and then we will go over some of these tomorrow in class, and we'll keep doing more of these problems. Any questions y'all got for me? All right, we got 2 weeks left, ladies. Finish strong. Let's get this chapter done. Sound like a plan?
Yes.
Don't sound too excited, please. 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 You're killing me with your excitement. Like, I know. You're gonna miss this so much in summer. You're gonna be like, oh man, I just want one more algebra class, please. Please, I just want one more. And I'm gonna say, okay, fine. We'll have a Zoom call just for Sierra. Sierra's probably rolling her eyes at me right now. So. All right, ladies. Actually, she may have fallen back asleep. Oh, she's wet. All right, Sierra, you can go back to sleep now. All right. See y'all tomorrow. Let me know if you have questions.